Hello, let's take a look at finding the inverse of a 3 by 3 matrix. We saw that for a 2 by 2 matrix, there's a nice little formula that we can go through to find the inverse. There's not really that formula for a 3 by 3, or it's not as straightforward. So for the 3 by 3 matrix, instead what we're going to do is learn a process, a method of finding an inverse. What's nice about this is it then works for any size of matrix. 3 by 3, 4 by 4, 5 by 5, the 2 by 2, any size square matrix. And there are multiple methods out there of how to find the inverse, so this is just one particular method that we're going to look at today. And it involves taking our matrix and adjoining the identity matrix to it. So I'm just going to rewrite matrix A, then adjoin the identity matrix. Now adjoin just means kind of attach. So I'm going to attach the 3 by 3 identity matrix. And the whole goal of this is to do elementary row operations, so add rows, multiply rows, and add them together, to this matrix A. And whatever I do to matrix A, I'm also going to do it to the identity matrix. And my goal is to make this into the identity matrix, and then this one will become A inverse. So as I do a whole bunch of row operations, so that I can make this of the form 1, 0, 0, 0, 1, 0, 0, 0, 1, like the identity, and I'm doing everything to this matrix over here, eventually this one will become the inverse. Okay, let's see that in action. And also with some notation, I can call this matrix A adjoined I, and my goal is to create I adjoined A inverse. That will be our result. Okay, let's try this out. So, first of all, I'm going to have to try and get this to be 0 and this to be 0. Okay, well, I already have one of them, so that makes it a little easier. So what's the first thing I have to do? I have to multiply the first row by -3. And I think as far as showing my work, what I'm going to do is with a different color, write the new row. So I'm multiplying everything by -3. So I get -3, -3, -3. And I also do it to the identity over here. So -3, 0, 0. Now what I do is I'm going to add this row, so that's the new first row, with the second row. And it's going to create a new second row. So for my matrix, it's now going to look like 1, 1, 1, 1, 0, 0. The second row now is going to be new. Okay, so notice how I wrote the first original row, but now the second row is going to be new. So I'm going to go -3 plus 3 is 0. -3 plus 5 is 2. -3 plus 4 is 1. Now onto the identity. -3 plus 0 is -3. 0 plus 1 is 1. And 0 plus 0 is 0. So that's how we go through to get our new second row. Okay, what about the new third row? Well, in this case, I would add first row with third row. But what am I trying to do? I'm trying to get a 0 right here, and I already have it. So in fact, I'm just going to copy my third row again. I don't need to do any work with it. 0, and then 0, 0, 1. So I figured this one out by going -3 times row 1 plus row 2. So I got there. Okay, what is the next thing I have to do? Well, the next thing I want to do is to get a 0 right here. So how would I do that? I'm going to go row 2 plus 2 times row 3. And that will give me my new row 3. So in green here, I'm going to write the new third row. So multiplying everything by 2 gives me 0, -2, 0, 0, 0, 2. Now my new matrix, same first and second row. So I'll just write those out. but now a new third row. So I go 0 plus 0 is 0. 2 plus negative 2 is 0. 1 plus 0 is 1. Negative 3 plus 0, negative 3. 1 plus 0 is 1, and 0 plus 2 is 2. Okay, so here we go. That was my new third row. Now I'm going to have to go back up because to get the identity, well, this needs to be a 1, this is a 0, 0, and 0. So I need to work on all of those. So I'll deal with this one thing later. For now, what I'm going to do is I'm going to move back up the matrix, and I'm going to use this third row to get a 0 right here. And then I'm going to use the third row to get a 0 right there. Okay, so I copied our matrix up here. And now I'm going to use this third row to eliminate this 1. So I'm going to go negative 1 times row 3 and add it to row 2 to create the new matrix. Now in this case, what's staying the same? The third row is staying the same. In the final thing, nothing's changing there. But the second row is going to change. So in green, I'm going to write my new row, which means I'm multiplying by negative 1. So I go 0, 0, negative 1, 3, negative 1, negative 2. That's that temporary new row 3. And I'm going to now add this with the second row. So 0 plus 0 is 0. 0 plus 2 is 2. Negative 1 plus 1, 0. Okay, moving over to the second matrix. 3 plus negative 3 is 0. Negative 1 plus 1, 0. And negative 2 plus 0 is negative 2. Okay, next up, and I just use the same work here, I'm going to use the third row to eliminate that one up there. So get rid of some of these circles. Just going to reuse that matrix. And to do that, I need to go negative 1 times row 1 plus, so that's negative 1 times row 3 plus row 1. Okay, so my new row 3, the temporary one, is 0, 0, negative 1, 3, negative 1, negative 2, kind of the same as last time. And now I'll go through and add row 3 with row 1. So 0 plus 1 is 1. 0 plus 1, 1. Negative 1 plus 1, 0. Okay, on to the second one. 3 plus 1 is 4. And negative 1 plus 0, negative 1. And negative 2 plus 0 is negative 2. Okay, there we go, that matrix. Now we just have a little bit left. I have two things left. I need this to become a 0 and this to become a 1. So the first thing I'm going to work on is making this become a 0. How do I do that? I want to use this second row to eliminate that 1. Okay, I want to use the second row because that way when I add this second row with this, I'm going to be adding a 0 plus the 1 here and a 0 plus 0 there. So it's not going to introduce any more numbers. It's going to keep my zeros as zeros. Okay, so how am I going to do that? Well, I'm going to have to go row 2 plus negative 2 times row 1. So let's multiply row 1 by negative 2. It's going to give me negative 2. I'm going to erase this to not confuse us. It's going to give me negative 2, 0, negative 8, 2, and 4. So for my matrix, the second and third row are going to stay the same. So I'm just going to write those already. Negative 3, 1, 2. And then the second row right now is staying the same. After I do the addition, it's staying the same. And I'm going to have a new first row. Okay, what is that new first row? So 0 plus negative 2 is negative 2. And then 2 plus negative 2 is 0. 0 plus 0 is 0. On to the second one. 0 plus negative 8 gives me negative 8. 0 plus 2 is 2. And negative 2 plus 4 is 2. Okay, So now we can kind of see, actually, we created this 2 and this 2 right here. And we have to have those become 1, because remember, what's our goal? Our goal is to make this the identity matrix. So what I'm going to do is I'm going to go -1/2 times row 1, and I'm also going to go 1/2 times row 2. If I do both those things, it will give me a 1 and a 1 in those spots. And what does that create for us? I go 1, 0, 0, 4, -1, -1, 0, 1, 0. So this one I'm just dividing by 2. 0, 0, -1. And the third row is all good, so we're just going to leave that as is. So I get -3, 1, 2. Okay, so now this is like the identity, which that means we have success, and this is A inverse. So I can say A inverse is equal to the matrix 4, -1, -1, 0, 0, -1, -3, 1, 2. That's our inverse. So that means if I take this matrix and multiply it with our original matrix, it will give me the identity matrix, because a matrix times its inverse is the identity. All right, so that's the process. It's kind of lengthy to find inverse matrices, but you can also go a lot quicker if it's not as slow and methodical as I tried to do it. There's your process for finding a 3x3 inverse, and that also works for a 2x2, 4x4, 5x5, any size square matrix.